Hello, today we're going to be talking about shifting, compressing, and translating basic functions. The first thing we need to do is identify the basic function. This is f of x. There'll be several functions that you have already learned the basic shapes of, and it could be a function that doesn't really have a definition at all. It might just be the graph of a function, but we should be able to create different functions by just looking at these shifts, compresses, and translations. They will look something like this. So given a function f of x in the graph that we know, we want to plot another function g of x where we translate that graph of f. There are several components to this that our new graph will have. So first of all is what we call an additive inside change. We will add or subtract something to this x value. We call that h. This is counterintuitive when we do things inside. So actually, if h is positive, if I subtract something positive, it will move something to the right h units. That might be counterintuitive because we might think if we subtract something, we move it to the left, but an inside change will move it to the right. If h is negative, the graph is shifted h units to the left. That's the inside change. This constant out in front is going to be a multiplicative constant. So we're going to multiply the function an outside change, and that's going to have the effect of stretching or compressing the graph vertically. So if this constant is positive and greater than 1, then it's going to stretch the graph vertically. Basically, it's going to take all those y values and multiply it by a. So if a is greater than 1, it's stretched vertically by that factor. If a is between 0 and 1, then it's going to be compressed vertically. So if we had a factor of, let's say, a third, then that's going to be compressed by a factor of 3. Every y value is going to be multiplied by 1/3. X value is unchanged. If a happens to be negative, then the graph is going to be reflected about the x-axis. Essentially, every positive x value or y value will become negative, and every negative will become positive if that a is negative. And if we're thinking about an inside change, so a negative in front of the x in the inside, that's going to flip the graph about the y-axis. It's going to make every positive x negative and every negative x positive. So if there's a negative sign in front of the x, an inside multiplier, the graph is reflected about the y-axis. Finally, if we're going to be looking at this additive outside change, this k, so we're adding that on to the y value. This is totally intuitive. So if k is positive, then that's going to just shift the graph up that many units. If k is negative, it's going to shift it down that many units. So that's an intuitive part of this graph. All right, let's try some examples. So here I have the graph f of x or y is equal to x cubed. And I'm going to want to plot the graph with a translation. G of x is equal to x minus 3 cubed. We should know about our basic graph. So our basic graph has these points at 1, 1, 0, 0, and -1, -1. So what does the effect of having an x minus 3 inside change do? Take a minute to think about it. Well, I hope I've given you enough time to ponder that. It's an inside change, so this is counterintuitive. So this is actually going to move the graph right 3 units. So a negative inside change moves the graph right 3 units. Essentially what I do with the original graph is I take every point and I just move it over 3 units. So 1, 2, 3 point, 1, 2, 3 new point, and 1, 2, 3 new point. Once I have those new points, I'm going to do the best job I can to draw the exact same graph. So it's going to be the exact same shape, but it's going to be shifted over 3 units. Hey, that doesn't look too bad. All right, let's take a look at another one. This one has more stuff going on. So this one says, given the graph of the absolute value of x, plot the graph of g of x is equal to -2 times the absolute value of x plus 1, and then an outside change of +3. There's several things going on here. So let's take a look at each one that's going on. I have a -2 out in front. So if you remember, that -2 is going to vertically stretch by a factor of 2. And it's going to reflect about the x-axis. So we might want to do these step by step. If I have those points on the graph, then I'm just doing an intermediate step. These points here, well, 0, 0 is going to be the same, but if I take, for instance, 1, 1, and multiply that y value by a -2, it becomes 1, -2. And the same thing with -1, 1, that becomes -1, -2. So in effect, I have my graph that looks like this now. But this isn't the total thing. This, what I'm plotting down here, would be my graph of f -2 times f of x. Okay. Now I have an inside change of +1. We know that is going to move things to the left 1 unit. Remember, inside change is counterintuitive. So this will move left 1 unit. Finally, we have an outside change of +3. This is totally intuitive. So this +3, we know, moves the graph up 3 units. So this one will shift the graph up 3 units. When we're done, we'll have something that looks like this. This moves to the left 1 and up 1, 2, 3. This moves to the left 1 and up 1, 2, 3. This moves to the left 1 and up 1, 2, 3. And then we can just sort of fill in the details from there. Our graph should look something like this. Our green graph will be the final graph. This one, unlike the other graph, this has symmetry with respect to the y-axis, so it's actually an even function. Although our green graph's been shifted away from that axis, so this one doesn't have any symmetry. I can also show you on the calculator that if I were to plot y equals the absolute value of x, that's actually under math. I go over to num, absolute value of x. Then I should be able to compare it with the new graphs, -2, math, absolute value of x plus 1, should shift it left 1. And then let me try to bring it back up here and do the +3, which should shift it up 3. So this is a good check. You can use your calculator to check this out. Hopefully things will be the same. Let's hope. I'm going to plot this new graph over here, maybe a little bit bolder. There we go. Let's graph these. So there's my first graph. My second one looks just like it. It has actually been stretched out by a factor of 2. It's been moved over 1 to the left and up 3, and it's been flipped over the x-axis. Well, I hope this helps. Thank you.